is next topic is the statistics collection using the command called as analyze. Using the command called as analyze. So I'm going to give you an example now. Let us continue with the same example. You have a book with around 10,000 pages. 10,000 pages is a big book. Obviously we have tables with 10,000 blocks, so that's why I'm giving you the analogy. On each page there are multiple rows, so 10,000 blocks, maybe 100 rows per each block, and so there are millions of rows there. And I asked you a simple query: select star from that table, let us say employee, where name is equal to Shekhar. If the index is not there, just imagine, as a human being, just imagine how painful it is, to go through that whole thing. And therefore, you say, okay, I'm not going to do a full table scan. I'm not going to read the whole book. I will create an index. So you painstakingly create the index. And therefore, index creation is a very time-consuming job. It requires a lot of sorting to be done. Index creation takes a longer time. But once it is done, then our jobs, simple jobs are kind of simpler. But which jobs are simpler? So let us say we have a huge table, and in that there are, each row has 4 columns. One is the employee ID, another one is the name of the employee, third one is the city. Let us say 3 columns are there. Now you have created an index. Index is, let us say, another small book, somewhere else. Index is another small book. You have created the index and that index is only on the name column. So in that index, that is, which is another small book, you have the names which are alphabetically arranged, and you have the page numbers, the row IDs of those names there. And now I write a query: select star from employee, where name is equal to Shekhar. Let's very quickly go to the index book, find out the Shekhar, it is alphabetically sorted, and get the row IDs and come to the actual book. Job is very simple. But now if you write a query: select star from employees, where city is equal to Bombay, what will happen? Will that index give you a better performance that you have created? Absolutely not. Because you don't have an index created on the city column, you have the index created on the name column. So it is very important to understand what type of queries people are going to write. If people are going to write a queries with the where clause, name is equal to Shekhar, then create an index on name. If they are going to write where city is equal to something, whether it's Bombay or Pune, that's a different thing, then create an index on city. If they are going to write on both, then you can create 2 separate indexes. Sometimes this will be used, sometimes that will be used. Or third case scenario is if they are always going to write a where clause where it says where name is equal to Shekhar and city is equal to Pune. If they are always going to write something like this, then create what is called as a composite index. Composite index, name is Shekhar, city Pune, name Shekhar, city Bombay, all those things, and then their row ID. So that is a composite index. So it is very important to understand how queries are written. How queries are written. So indexes help only when you know the where clauses. So let us see where the indexes kind of help us. So select something from something where city is equal to something. The index will be helpful if we have the index on the city. That is kind of very obvious. Now if I want to do a delete, will the index be still helpful? Index will still be very much helpful, because before you delete, you have to identify which row has to be deleted. So it is, search is still going on. I want to delete a row on page number 25, but I need to know that there is a city is equal to Bombay. So during the delete also, index is very helpful. During the update also. So it's not just the select statements, it's any statement where there is a where clause, and that where clause has to be that column. So that is an important thing. People will ask you this typical question, that I have a query, they will give the query, and in the where clause they will say where employee ID is equal to 25. Can you make this query run more faster? So your question should be, employee ID is equal to 25. Oh, looks like, is that a primary key? Yes, it is a primary key on the table. If it is a primary key, the index is already created. And since the index is already created, that is going to be the fastest query. Oracle is going to use the index, find out the row ID, then going to do the table. And therefore many people say always do the searches with the primary key in the where clause. If you use the primary key in the where clause, your search is going to be very fast. Why? Because there is an index on that primary key column. Always, because primary key has an index, unique index. That is one thing. So where else the queries can be made faster? So another thing that I will tell you. When you join two tables, employees and departments, you say employee.department ID is equal to department.department ID. What are you trying to do? What is the join? Join is basically a loop. Okay, join is basically a loop. So let us try to understand what a join is, and then you will understand the importance of an index in that join. So let us understand what join is. Now in a join, there are two tables. They are to be joined. I will give you an example that I always give, which is, let us say there are three names here, A, B, C people, and then I have given you a telephone directory. Okay, and I said, okay, please find out the phone numbers of these three people. So what will the smart person do? He will actually say, okay, Shekhar, that's the first name. So he will go to the smaller table, only 3 rows, Shekhar, and then he will loop through the entire telephone directory to find out is Shekhar there. Okay, it will go to ABCDS, it will find out Shekhar over there, and it will come out of the loop. Okay, Shekhar's phone number is found out. Then the second person, that person, there would be one more one more loop, and the second person's phone number is found out. Third person, one more loop. So 3 loops will be done, and the phone numbers will be found out. That is how people will do it. A dumb person, on the other hand, could do the exactly opposite. He will say, okay, I have 2 tables. I can start from this side. So he said, who is the first name in the telephone directory? It is the Adam, somebody whose name is Adam. So he said, is Adam in this smaller list? No. So I am not able to find the phone number. Second guy, who is that? Barbara, B. Is Barbara in this list? No. So the join is not done. Then the third person, likewise, he will go through the loop 1 million times if there are 1 million phone numbers in the. Finally, he will be able to find the join, and he will be able to kind of get the answer, but he has done it in a different way. Okay, and that is where Oracle will also think about this thing. Oracle has to know that there are 2 tables, one is smaller and one is bigger. Once it knows that one is smaller and one is bigger, then it will say, I will start from the smaller table and do the joining. So I will go through the loop less number of times. If Oracle doesn't know which one is smaller and which one is bigger, Oracle will get confused, and it may very well happen that Oracle will start from the bigger table, and then it will do the join to the smaller table, and the execution will take longer time. So it is kind of important to understand how loop works. This is how the loop works, employees and departments and all that stuff. And as you can see, you have gone through the loop here, but also the telephone directory was sorted. Just imagine if the telephone directory is not sorted in this case. Again, the looping will take a longer time. So therefore, in joining, it's a loop, and on top of that, data was sorted, so the join was faster. So in the joining, if the data is not sorted between the primary key and the foreign key, then the sorting will happen first. So Oracle will first do the sorting of the one table. Once the sorting is done, then it will perform the join, because it knows that once the sorting is done, the join would be faster, and then it will actually go through the loop. So Oracle is going to do 2 things: sorting of one table first, then the loop, smaller table first and the bigger table the next one. That is how the join will work. And if we had already created an index on the joining column, so what are the joining columns? Our joining columns are employee.department ID is equal to department.department ID. This is our join from the employee and the department. Department.department ID will already have an index, because that's the primary key there. Employee.department ID will not have an index. It's a foreign key pointing to the department ID. So if we create an index on this column, what will happen? Actually, our join will run faster. Sorting, what is sorting and index creation is one and the same thing. Okay, sorting is one and the same thing as index creation. So wherever there is sorting is required, index will be very helpful, and it will make things run faster. So our discussion is now, we know that index will avoid full table scans and it will make things run faster. We are just trying to find out areas where index can make things run faster. This is definitely one area in the where clause. Second area where indexes will make things run faster is when you create an index on the joining columns. When you create the index on the joining columns, the loop would also run very fast. Third thing, So as you can see, sorting is avoided because index is already created. Third thing, if you say order by something, order by city requires sorting. If the index is already created, that index will be utilized, sorting will be avoided, and therefore things will run faster. So whenever you write an order by command, and if that order by clause, and if that order by is going to be more frequently used for all other things, all other queries, then definitely create an index on the column over there. Similarly, distinct, whenever you use a distinct clause, what is happening? In the distinct, we are actually getting rid of duplicates. The best way to get rid of duplicates is to first sort the data. Once we have sorted the data, we know the duplicates are right next to each other, and we can get rid of one of the duplicates. So obviously Oracle knows that, and Oracle will first sort the data, then get rid of duplicates, which is what happens in the distinct. And therefore, if you have already created the index on the column where you are going to do distinct, then the query will run faster. So indexes is one of the best ways to make queries run very fast. Where to create index is something that you need to know. Many people say that, okay, if your query is running slow, then what should you do? The typical answer, everybody knows that create indexes. But where to create indexes, that is the important discussion. So to avoid sorting, you should create indexes. Sorting is done over here, sorting is done over here, sorting is done when the joins are there, sorting is done when the orders, order by there. Also group by. So fifth is group by, sorting is done. Sixth is union. Union is also, you remove duplicates. So sorting is done there also. So all those things can be made faster if we create proper indexes. So this is the discussion about where indexes can make things run faster. And now I want to talk about the statistics part with the help of our discussion that we did over here. So again, let me repeat this thing. On which columns the index should be created. The columns, whatever you use in the distinct, whatever you use in the where clause, the joins, the order by clause, the group by clause, unions and all that stuff. That is where you should create indexes. And once we create the index, our job is done. Oracle will automatically take care of the remaining things. Oracle will use the index and it will kind of take care of things. So when I discussed about the rule-based optimizer earlier and the cost-based optimizer, which is a newer thing, rule-based optimizer had one rule. And the rule was, if a table has an index on the column which is there in the select clause, use that index to find out the row ID, and then once you find out the row ID, go to the table and find out that row very quickly. That was the rule. That is still the best rule. But now there is a but to that. What is that but? The but is, you will not get results faster for all types of queries like that. There are exceptions. What are those exceptions? Let me tell you the exception there. Let us say that there is a table which is a small table. Obviously, if a table is very huge, 10,000 blocks and everything, index will make things run very fast. Okay, but there is a table which is only one block. In our project we created a table called as region. We created a table called as, even our products was very small table. Okay, 100 rows. And all those 100 rows could fit in one block. So there were very small tables that we created. If the table is just within one block, that means entire book is just one page book. Now on top of that, you are creating an index which is also one more page. Okay, so what has actually happened now? So for a small table you have created one more index, and now since index is created, Oracle's old rule says that what? That actually go through the index first, find out the row ID. So obviously you have to read the whole page to find out the row ID, and then go to the real page and find out the row there. So what they have done, they have read really 2 pages. Okay, they have read 2 pages. But if they had done a full table scan, how many pages they would have read? How many IOs blocks they would have read? Only 1. So actually by reading the index, they have slowed the actual performance. And this happens many times with these smaller tables. So the older rule that Oracle had in the rule-based optimizer, that if there is an index, use the index and go to the table, is not good anymore. But then how does Oracle know that, okay, this table is very small? To know that table is very small, it has to read it. So again, to read the table, and then it will realize, okay, this is so. We have to do certain statistics collections. So we have to first run some command. That command is analyze command. And by running that analyze command, Oracle is going to go and read the data from that one table. Analyze, the command is this. I will tell you, analyze table, employee, and we say compute statistics. Compute statistics. This is the command that we use. Very important command. From the performance tuning point of view, very important command. We execute this command, and this command takes a long time. It will go and read each and every row from each and every block in that table, and it will start analyzing the data. It collects certain information about what? About how many rows are there in the table. That is number one. How many rows are there? So this is what I call as statistics. So stats is, okay, number of rows in that table. Second thing, how many blocks are there? So total number of blocks. Okay. Third thing is how many empty blocks. So for example, you may have a 1000 page book, but out of those 1000 pages, only 3 pages are filled. Okay. So you need to know really, even though the table is big, you have less data in that table. Could that happen? Yes, initially the table became huge because we had huge data, and after that we deleted it. Once the data is deleted, the pages would be blank. The blocks would be blank, but still that table will have thousands of blocks. So empty blocks, total number of blocks. Then the fourth thing is average length of a row. Whether it is 20 bytes or 15 bytes, that information is also there. Then certain information about the data also, the cardinality of the data, we'll talk about cardinality of the data. Cardinality of the data. So all those things is what I call as statistics. When you execute this command, analyze table employee compute statistics, all this information for the employee table is collected and it is stored inside what we call as data dictionary views. Data dictionary views is one of the data dictionary views that we know is user underscore tables. So if you go to user underscore tables, you will see all these columns over there. Before executing these commands, those columns will be null for that table. After executing this command, those columns will have certain values. So what we have done by executing the analyze command, we have collected the statistics for that table and we have kept that into the data dictionary views. We have kept that into the data dictionary views. What is the purpose of doing this thing? When we execute any command, the optimizer is going to go and read the statistics. It would know that this table is almost empty. This table is very small. It has only one block. This table has index. So all the information about that table will be now read by the optimizer. And now optimizer can make a very smart decision whether to do a full table scan and get the answer quickly, or whether to read index and then the actual table and get the answer quickly. So the information about the data is very helpful to the optimizer. Very helpful to the optimizer. And if this information is not collected, this information is not there, then in that situation the optimizer will make a wrong decision and your performance may be very slow. I will give you an example. You should do this exercise also. Create a table with around again 2 million rows, 2-3 million rows. Okay, write a PLSQL program to do that. As the table is growing, the total number of blocks, so your book will keep on increasing. And after the whole thing, you actually run a command, select count star from that table. Okay, find out how much of time is required to execute that command. Okay, how do you find out the time? Set timing on. Once you do set timing on, it will show you, how much of time is required to execute that command. So let us say it took 5 milliseconds. Then delete all the rows from that table, commit them, all the data will be gone. All the data will be gone. And then after that, execute the same command, select count star from that table. There are no rows in that table. So you should get the answer 0, but you should also get that quickly. But you will not get that quickly, because your optimizer will think, you know, the data is still there, and it will keep on reading each and every block, and it will read all the blank pages, all the blank blocks in your table. It will do a full table scan, and it will finally give the correct answer of 0, but it takes time. So why this has happened? Because optimizer doesn't know how big the table is. So in order for optimizer to know that, we should actually execute this command from time to time. What is that time to time? Maybe, you know, around 15% of the data is changed. If we delete 15% of data, if we add around 15% of data, update 15% of data, that's a good rule of thumb that you should execute this command. And the optimizer would know that this table has so many rows, and it will take proper decisions. So analyze table is a very important command, and you also, this is a little older command, and now with the newer versions of Oracle, they have a package for that. What do they do? There is a package called as dbmsstat, dbms_stats dot gather schema stats, and here you just say HR or your name, like AP user 20. So what will happen, and you do execute of this, exec, execute dbms_stats, gather_schema_stats, and the name of the schema. It will go and collect the statistics for each and every table and store that into that data dictionary view or those data dictionary views, and your optimizer will now be very happy with the most recent statistics. It can make better decisions. Okay, so these are the 2 points that I wanted to kind of explain. What is an optimizer, and what is the statistics collection, and how they kind of work together with all these things. So the things that we should know, again, what is the stats? What is the statistics collection? It is done by either the analyze command or the dbms stats package. In the dbms stats package, you do the describe. I think, you know, we are all PLSQL developers, we can describe, and you will see there are quite a few procedures there. Gather schema stats, gather table stats, gather index stats, you know, all those options are there. But schema stats seems to be the most appropriate because it will do it for the whole schema. What is the statistics? Why it is collected? Most important is why it is collected. Another most important thing is when should it be collected? How frequently, that means. As I said, 15% of data, 10 to 15% data changes, we should collect the statistics. Many people collect the statistics once a month. Many people collect statistics after loading huge amount of data. In our project, when would we collect statistics? Initially there are 0 rows, we load huge amount of data, then after that we should collect statistics. Okay, and if no data changes happen for 1 month, don't worry about it. Then after 1 month we again load a huge amount of data, collect statistics. Small changes here and there, you know, 10, 20, 50 lines, you know, addition, don't bother about that. So that is when to collect statistics is kind of very important. Then the second point that we mentioned here was what? The what should I say? The full tables, the looping, okay, or when indexes are used. This is kind of a very important thing that we saw during the joins, during the group by, the order by, all those things, the indexes are used. You should know on which column the index should be created. That is very important. Based on the, so when indexes are used by the optimizer, so this is the actually by optimizer. So these are the kind of 2 important points from the indexes point of view. Now in the next section I will show you. Yes.
इंडेक्स पेज इंडेक्स जेव्हा आपण बनवला तर एक वेगळा टेबल तयार होईल. तिथे पहिल्यांदा सिक्वेन्शियली सर्च होईल, रो आयडी सर्च करण्यासाठी. मग ऍक्च्युअल टेबल मध्ये सिक्वेन्शियली सर्च होईल?
नाही, ऍक्च्युअल टेबल मध्ये रॅन्डम सर्च, बिकॉज वी एक्झॅक्टली नो वेअर द लोकेशन इज. इट्स अ पॉइंटर टू दॅट रो. So what we are getting actually is a pointer to the row. Row ID is kind of, you can say it's a location of the physical row on that on that disk. So it's a pointer. So since we have a pointer, we can directly go to that block and the row. And we don't have to do any sequential. file thing, it's a random access thing.
आणि दुसरी गोष्ट म्हणजे
analyze table.
समजा तर ते युजर टेबल्स मध्ये काहीतरी अपडेशन होणार तर ऑप्टिमायझरचा रोल कुठे येतो?
ऑप्टिमायझरचा रोल द sequence is first thing is data gets loaded into a table. Once the data gets loaded into the table, we are running the query. Who is giving us the execution plan? The optimizer is giving us the execution plan, and optimizer once decides the execution plan, it is executed. But optimizer doesn't know that we have loaded the data. Okay, for optimizer to know that we have loaded 10,000 rows, 20,000 rows, we need to do the analyze. So we do the analyze command is going to populate data dictionary views, and now the optimizer will go to the data dictionary views automatically, and it will say, okay, this table has 20,000 rows, it's a big table, so I should use the index. If the table has only 10 rows, then I should not use the index. I can just do a full table scan, one page, it will be faster. So optimizer has to know the sizes, optimizer has to know the row size and all that stuff. Then only things will work. No complaint will come from optimizer. Optimizer is just going to check, what is the size, do I know it? If I don't know it, I'm going to take my regular action. So again, people will say, somebody is complaining about performance. A user comes in and he says that, I clicked on this thing and it's slow. Okay, what to do? So first thing, you have to identify what is happening behind that click. Or you are running a stored procedure. What is happening in that stored procedure? You have to identify the SQL statement, insert, update or delete or whatever. Once that statement is identified, then the next job comes in. What is the execution plan for that statement? And I will in the next segment, I will show you how to look at the execution plan. Because we are just understanding all this stuff, that optimizer will do this, optimizer will do that, but what exactly it is doing, how do we find that out? And that is what the command that we're going to talk about is the explain plan. Explain plan. And we will see that command. So that explain plan command, or in fact there is an easier way, set auto trace on, I will show you that. That command will show you the real execution plan of your optimizer for that specific query. And if that execution plan shows that the full table scan is happening, indexes are not being read at all, then you say, alright, this is a big table. Why the indexes are not being used and this and that. So you create indexes if there are no indexes. If still the optimizer is not using indexes, maybe optimizer is thinking it's a too small table. Then you collect statistics and then optimizer will know, okay, this is a big table and then therefore I need to use the index and then I need to find out the row ID from the index and go to the table and do the actual table scan. Not a full table scan, but a table scan to find out the row using the row ID. So that is something I will show you actually during the practical, and that is where explain plan is a command which will show you the execution plan of any specific row. This is the older way of doing it. There is a better way of doing it now, kind of set auto trace on. This is a SQL plus command. Inside SQL plus, if you type this command, then what is going to happen? Every SQL statement that you type after this will be executed, and immediately after that you will see the execution plan. Okay, so we're going to do that exercise of the execution plan.